Okay, so let's assume that we have this diode here. Actually, we do have this diode here, and then when switch 2 is on and switch 1 is off, we end up with something like this. Okay. So as I mentioned earlier, the two switches can never be on at the same time. So let's assume that we have these gating signals for our switches. This is for switch 1 and this is for switch 2. Let's assume that switch 1 is on here and switch 2 is on here, and then after this time they repeat. So this is the time, this is the period. Okay, if that's the case, let's see how the output voltage and output current will look like. So let's first look at the output voltage. So in this case, and then like I want to also like draw the output current. Okay, so just like keep these notations in mind, these polarities in mind. So when switch 1 is on, this is what we end up with, right? So here the energy goes from the source to the load, right? The output voltage, it's going to be equal to Vs, right? And the output current is also, if I start from 0, it's going to increase like this. Okay. Now, I turn this switch off at this point, right? And switch 2 is not on yet, right? We stored some energy inside this inductor, right? So this inductor has been energized, okay? Now, switch 1 is off and switch 1 is open, right? When switch 1 is open, now what happens to the basically the inductor, right? So there is some current stored in the inductor that it has to get released. How does it get released, right? So it's gonna release in, it's just basically it's gonna go to 0 at this point. It's like the voltage across this, it's gonna be 0, and the current, it's gonna release itself, and what's the output voltage is still 0, and the current goes from the inductor, right? And in this case the polarity is gonna change. The polarity is gonna change because we are in this point, right? Like this is open and this is also open, right? And we have this diode here. Okay. Now the polarity of this diode, this inductor is going to change, and the current, it's gonna go release itself inside this diode, and then we would have current flowing through this loop here, right? Again, the direction of the the direction of the current is according to the direction that we chose for positive current. So you see it's still current, but it's reducing, like, and the value of it is reducing. Okay, sorry, I was like a little bit not sure if I did this correctly, but now I'm sure that this is correct. So like it's gonna, basically the current finds its path through D2, right? And it would force D2 to be open, okay? Now, at this point, what we did was turning this switch on or closing this switch, right? Once you do that, the output voltage is gonna remain 0, right? Because it's connected here, it's short-circuited here. Now, what happens here is now the back EMF of the machine, it's gonna charge this inductor. And the polarity of the inductor, it's gonna be this way, right? But in this case, it's absorbing energy, right? But the direction of the current is in the negative direction. So it's gonna go like this and up to this point. So it's gonna increase in the negative direction, right? And then once you open this again, at this point, this switch is open and this switch is still open as well. We haven't turned this switch on. Like for this period, if I'm just like, if I do this alignment here, so you see that here at this point, this wasn't perfect alignment. At this point, the switch 2 is opened, right? But switch 1 is still not closed, right? So what happens here is now the energy stored in the inductor has to release itself, the current that we store in the inductor. So it's going to release itself through diode 1, right? And in this case, basically the inductor is energizing the source. The power flow is from the load to the source, right? So here, this is what happens. So the energy stored in the inductor releases itself in the source. If I write down like the switches or diodes that conduct here, S1 is conducting the current. This one, D2 is conducting the current. Here, S2 is conducting the current, and here D1 is conducting the current. Okay, so it was a little bit more complicated than the other case. Now let's look at, I'm just gonna erase this one. Let's look at the modes of operation. So in this case, both current and voltage are positive, so we are in the first quadrant. In this case, again, both voltage and current are, or I didn't draw the voltage for this part, like, but this is what we have. If diode 1 is conducting, this is what we end up with. So the voltage is still positive.